Alright, howdy everybody. My first little maker video with my new DJI Osmo Pocket 2. I've been thinking a lot lately, as I tend to do, and I was thinking, just what's it all come to? Have I done everything I want to do in the audio world? Of course not. But I've made a guitar pickup. I've made a guitar. I've made effects pedals. I've made an amplifier. I built a speaker cabinet. And then I realized, I'd never made a speaker. And for a while I thought that was maybe outside of the realm of reasonable endeavors. And I saw a video a little while back on some guys doing 3D printed speakers. And so that got me inspired, and I thought, well, what the heck, let me give this a go. So I designed some stuff up and gave it a go. And it didn't go like I expected, but we're going to go through that, and I'm going to show you the results, and we'll talk about it all. So this should be interesting. So, okay, first of all, before we get into it, now, most speakers, as everybody knows, have magnets in them. And maybe everybody doesn't know, but there's a voice coil, a coil of wire that's in this magnetic field, and that's what drives the speaker cone. So the volume of the sound coming out depends on the strength of the magnetic field and the strength of the current through the coil. So that's the conventional way. Those of you who might have been watching me for a while, a few years ago I built an amp for a friend and put in some special speakers from a company called Fluxtone. And these speakers use what's called a field coil magnet. So instead of a permanent magnet, we're using an electromagnetic field. Now the advantage of that is that with this electromagnetic field, we can control the strength of the magnetic field, right? And we can reduce it in strength and thereby reduce the volume, or increase it and increase the volume, give the speaker maximum efficiency. Of course, there's thermal limits on how much power you can give to the coil before it starts overheating and whatnot. So, these are parameters we have to work within. But the field coil magnets with the speaker, the amplifier doesn't see the strength of the magnetic field. The impedance doesn't change for the amplifier. So it's a wonderful solution to turn down the volume without changing the characteristics of the amplifier, the tubes, or whatever, in any way whatsoever. So it's the only perfect solution to volume reduction without doing some compromises somewhere along the line. So that in mind, I thought, what the heck? I should try to make a field coil speaker instead of just a regular speaker, right? So that's what I did, and we're going to see the results here. All right, so the first step was designing what's called the spider. I think it's called the spider. Anyway, it's this support which holds everything in place, right, but lets it move backwards and forwards. And this is the pictured here. We've got the rear spider. I guess it's called the spider in the back, and it's called the support in the front. Anyway, the key here is we've got these ridges here that allow it to flex in a forward and backwards direction. So we want to design this as thin as possible, right, for flexibility, and print this out of a TPU. So the inner diameter is made to match my voice coil, and the outer flange to mount to my um, voice coil body on the speaker. So step one was writing this OpenSCAD program and having this parametric algorithm to produce this output so I could easily modify it. So I've got a few variables here I can flip and make it render a version for the outer support as well. But so that's the basic idea on the support. And here's a rendering of the whole speaker body here. So we've got the outer support, a speaker cone, which is transparent here. You see the hollow region here inside the voice coil. We've got the spider there on the body, and then in the back here you see there's this blue component, and that's the field coil, which gets inserted into the body and goes around the outside of the voice coil. So what I just assumed from the get-go was that I've got a coil inside a coil. All the flux is contained within the coil. It ought to be super efficient. This will work no problem. And so that's what I went with. Now, what's hard to see here is these veins that go up. They're separate. They're part of the base, the ring, but then the center part, the body, it's a separate part for printing that, right? So I can make the whole thing printable. Let me see if I can show that here. Toggle my variables. Okay, so here now we can see the body without the supporting frame, and I've also got a cutaway. Here we go. So, in this cutaway, we can see we've got the outer body here, and this blue part, it's got this cylinder on it, and in this space right here, that's where the field coil goes, and then this part right here, that represents the inner voice coil winding on this form, which gets connected to the speaker to drive it. So that's the design. Fairly simple, not too many parts. Everything's easy to print. For the speaker cone itself, I printed a buck form that I could use to 3D to mold, 3D print the buck, and then mold, vacuum form the actual speaker cone out of some thin plastic. I think I ended up going with PETG. I was thinking of polycarb, but yeah, PETG just turned out to be the easiest to get. First up, we've got this the frame here, right? The basic frame of the thing. And so this was the prototype one I printed, and then I realized I could not vacuum form a cone this big, so I had to make a smaller one. Thought I'd show you that. And here's the buck, as it's called, for forming the speaker cone. I've used this for the vacuum forming. There's a tiny hole in the center there that lets suck the air out of there and suck that down there and give a nice little dome in the center. So that was simple enough. And here's a couple of my test prints for the spider. And this just turned out to be way too stiff. This one too. So I had too many ridges, right? Means that you're it's really hard to move back and forth. You want a lower angle of attack on making that deflect, right? And I've got a very high angle of attack on that now, so it makes it very hard to bend that. So here is one of the the first voice coil attempt I made, and this ended up being slightly too big to fit inside my field coil. So really hard to get that winding perfect on there. And so this, and you see what happened at the end here. It went too far, and I have not so well contained coils there. So this turned out just to be a learning experiment here. I gave it a good coating of glue as I was winding this, and make sure it's all held together nice. So for making the voice coil, I modified my pickup winding machine and used it, and used a 28 gauge wire. That seemed my first attempt at or first design of the voice coil. I was thinking, well, yeah, 2-inch voice coils or whatever, and then I started doing the calculations on the wire and everything, and it just seemed like it was much more practical to go with a smaller coil to get my impedance right and everything. So it's about a 25 millimeter here. And I ended up just decreasing the diameter of the voice coil form, and so that my outer diameter here was adequate to work with my design. So here's this finished speaker I ended up making. Gosh, it looks great, but how does it sound, right? That's what it's all about. So by the way, what do you use to glue TPU to PETG plastic? Well, turns out Gorilla Glue. This is a polyurethane-based glue, and TPU, thermal polyurethane. Those are going to bond, and it's also kind of flexible, and also bonds well to the PETG. So that's the go-to glue here. And so you can see the different parts here. I'm gonna flip this over and actually get to make use of this frame here. Support this here. So you can see we've got these wires coming out, two sets of wires. Now this one's here on the bottom, that's for our voice coil, and on the top this is for our field coil. Okay, almost forgot to show this. So this is this ended up not quite being dimensionally correct for my final model here, but here we can see what's going on with the speaker body. So we have the would be voice coil here, and you can see how that fits in there. This would glue on like this, and then this part right here would have our field coil wound on it, and it goes in like that. This little ring there at the bottom helps it stay all centered there. And this might have worked. It was a little bit close. Might have rubbed there with the voice coil, and I clearly just didn't have enough room. I'm not sure why that isn't perfectly centered, but anyway, didn't have room for the field coil adequately, so I went with another slightly modified version here, which is what we see here. Let's hook this thing up and see what happens here. So I've got my speaker output here. I'm going to connect that voice coil. And this one half of the field coil. And here will be the other half of the field coil. So I've got an adjustable power supply over on the side right now. It's set to almost, so we're about 9 volts here. And if I hook this up, that's now making a 400 milliamps, 0.4 amps. So let me start some music playing here. So we've got a signal and we don't hear anything. And now I can just barely hear over the noise of the fan on my power supply 3 feet away. I can barely hear just a little bit of noise coming out of this speaker. I don't think you can hear that. So let's go ahead and up the voltage here for a little while, huh? All right, that's 16, almost 17 volts for 0.7 amps now. I can just now begin to hear this. Let me get Osmo close, see if Osmo can pick this up. So, I don't know if you can hear that. It's sort of technically working, but boy, we can't hardly call that a speaker, can we? So okay, well, there's obviously something wrong with the magnetic field. What happens if we take these speakers, these magnets, and put them inside here? Boy, I can feel the pull in here. It's pulling me in. Wow, there's a lot of pull there. I can feel the vibration on the magnets. So, now we hear something. So we expect this to not be too efficient because my surround is still pretty stiff. But now notice, yeah, I get about a third of the way in. It's kind of like a peak in our volume. If I keep going all the way in further, the sound actually gets quieter. Well, of course, that might have been the song fading out. Here we go again. Yeah, you can see when I stick it all the way in, we basically lose any sound. So clearly there's more flux at the magnetic flux at the end of the magnet, and once we get that past the end of the voice coil, it's very little flux interaction there. But what's really interesting is it seems to be about a third of the way in here where I can feel the strongest pull on the magnet, and also hear the loudest volume from the speaker. So, okay, these were magnets. What happens if we just take some steel and put it inside there? And what happened? I had a bolt here. Alright, so here we just have a plain and a steel bolt. Might be a grade 8, I'm not sure about that. Now once again, once I stick the bolt all the way in, and the end is going past the end of the voice coil, we're reduced. We get it in the middle here. So oh, the darn song's fading out again here. So right about there seems to be the highest volume level. So if I hold that out and look, okay, so that seems to be about matching the depth of the voice coil in there. So by the way, already here I can feel the heat building up in this field coil. And we bring our little measuring device here. We're yeah, taking a peek in there. It's getting warm in there. So I'm gonna turn the power supply off and let's just talk about what we're seeing here now. So the formula for the strength of the magnetic field from a coil of wire like this, it's not just the number of coils that you have. The magnetic permeability, mu, of the volume contained in here is directly related to the strength of the magnetic field. So, by having an air core here, I lost out on having a strong magnetic field. So that's why it didn't matter really. I mean, it helped a little bit putting some magnets in here. Look, yeah, right now we don't even have the power supply on, and here we have sound from putting the magnets in. And now check it out. we even get, just from putting this bolt in, I don't know if you can hear it, but I can hear just a little bit of sound from just having the increase of permeability from the bolt here, and it's just the voice coil interacting with the induced magnetic field in the bolt here. So that's really fascinating. So what have we learned? Well, we've learned that an air core solenoid is grossly inefficient, and the concept seems sound enough, but this is clearly not a successful implementation. So phase 1 here, definitely complete. Phase 2 will need to be a revised design that replaces this this external field coil, right, with one internal to the, I'm going to go internal to the voice coil, and have an iron core, so that we've got the permeability there to increase our magnetic field. And when that will happen, well, I can't tell you, folks. We got a lot of projects going on, but at some point in time, stay tuned for part 2 on the 3D printed field coil speaker. Thanks for watching. Catch you next time.